All right, today we're learning about solving systems of linear equations by using substitution. I know I've got this when I can use the substitution method to solve a system of linear equations. So the key vocabulary is the substitution method. It's another method besides getting lucky with trial and error or graphing the equations that can be used to solve systems of equations. Is called the substitution method. You can solve one equation for the variables and then substitute the new form of the equation into the equation for the solved variable. Okay, go ahead and stop this and read. All right, number 1A, use the substitution method to solve the system. Okay, so what I'm going to do is one variable has to be solved for. The y is already solved for in the first equation. So I'm going to take what the y equals, and I'm going to substitute it into the y in the second equation. So I'm going to get 4x plus 2 times what y equals, which is 3x minus 6, and set it equal to 8. So basically, I'm rewriting the second equation, but I'm plugging in or substituting what y equals. Okay, so I get negative 4x plus distribute, so 6x minus 12 equals negative 8. Combine like terms, so 2x minus 12 equals negative 8. Add the 12, and you get 2x equals 4. So you get x equals 2. Now, once you found that, you can plug that into any x. I always plug it into the one that you already isolated for. So y equals 3. Instead of 3x minus 6, 3 times 2 minus 6. So you get 6 minus 6 is 0. So the ordered pair that these two equations would intersect at is 2, 0. Okay, so in the first one, the y was already solved for. It was already isolated. So let's do one that's not. You want to pick the easiest one. You can solve for the x or the y in either equation. So I'm going to choose this x, just because. All right, so if I did that, to isolate this x, I would add 3y on both sides. So my equation would be x equals 3y plus 16. Now, since I've isolated the x in the second equation, I'm going to substitute it in the x in the first equation. So instead of 2x plus y, I'm going to say 2 times 3y plus 16 plus y equals 11. And then I'm going to distribute that. So 6y plus 32 plus y equals 11. So I'm going to get okay, so I'm going to get 7y plus 32 equals 11. I'm going to subtract 32 from both sides. I'm going to get y equals negative 21. So I get y equals negative 3. And then I'm going to plug that into the original isolated equation that I did. So y equals 3 times negative 3 plus 16. I get x equals negative 9 plus 16. X equals negative 9 plus 16 is 7. So my answer would be 7, negative 3. And that actually should be a parentheses, not a bracket, because that is actually a coordinate that you solve for. Okay, 1C is one that you're going to do, so go ahead and work it out. And you should have gotten 6 1/2. All right, now, again, we're going to keep doing the same thing because this whole section is on the substitution method, so it's just different problems. Okay, solve the following system of equations using substitution method. So Since y is already isolated, I'm going to plug what y equals into the second equation. So 8x minus 4 times 2x minus 5 equals 20. So go ahead and distribute that. So what you see happens, look, 8x minus 8x goes away, and I just get 20 equals 20, which is a true solution. So when I get a true statement, then I know that I have infinite solutions. Okay, so this one, you would say if you come down and all your variables cancel out and you get a true statement, it's infinite solutions. When you get a result like the previous one on the slide that's obviously true for any value of the replacements for the variables, this indicates that the two lines actually represent the same line. There are an infinite number of solutions for the system. Any solution of one equation would automatically be a solution for the other equation. This represents a consistent system, and the linear equations are dependent equations. So you would say the system is consistent dependent. So solve the following system of equations using the substitution method. Okay, so I need to isolate one variable first. I'm going to isolate this y. Typically, you want to isolate the variable that has a coefficient of 1 or -1. It's just easier. So, okay, I'm going to work with this. So I need to move that 3x to the other side. So I get -y equals -3x plus 4. And divide everything by a -1. So I get y equals 3x minus 4. Now I'm going to substitute this into the second y. So I get 6x minus 2 times 3x minus 4 equals 4. So when I do that, I get distribute. So you get -6x plus 8 equals 4. Your 6x's are going to cancel each other out, and you'll get 8 equals 4, which is untrue. Therefore, if you get a false statement, it's going to be no solution. No solution. So if you get a true statement when all the variables are gone, it's infinite solutions. If you get a false statement, it's no solution. So when you get a result like the one in the previous slide that is never true for any value of the replacements for the variables, this indicates that the two equations are actually parallel and never intersect. There is no solution to this system. This represents an inconsistent system even though the linear equations are independent. So remember that when you have parallel lines, you don't have a solution because the solution is where they meet. So if they never meet, you don't have a solution. So it's an inconsistent system. All right, you go ahead and try this one. Go ahead and pause the slide. And the answer is no solution. So they are parallel lines. All right, this is some extra practice. Go ahead and pause the slide and try these with substitution. I do want to point out one thing real quick before I show you all the answers. On H, you see how there's a lot of fractions? We can get rid of all those fractions by multiplying by 2. So you'd have just x plus y equals -6 as your second equation. That would be a lot easier. Okay, so there are your answers. So I know I've got this when I can use the substitution method to solve a system of linear equations. But do you really understand? So what is the first step in solving the system of equations given below using the substitution method? You would substitute the 2x plus 6 for the y in the second equation. Show your work for this step and find the value of x. Go ahead and pause it. And then that should have been your answer. So that is it. Let me know if you need help.